Hi, our main topic is how CPU works, how exactly what is CPU is, and what is happening under the hood. But right now we are trying to use 8086 architecture. So it's like basically the architecture, the CPU architecture, starting from 1986, and I believe I believe in 1986 or 1886, and this is really the basic architecture of a CPU. So I'm just gonna give example using this kind of architecture rather than just speaking some kind of theory thing about CPU. So this is how CPU looks like. I know when I first encountered this kind of stuff, I genuinely had no idea what's happening under the hood because I mean like this kind of BIU and EU and this kind of diagram is literally nonsense to me, right? And actually, I didn't figure out right even now, but I'm still learning it. So I'm just gonna explain how we how this is it. So let's see. So forget what all those kind of stuff. I'm just gonna try to explain later. I'm just gonna explain like this kind of important stuff. You know, if you like if you're trying to use some kind of like CPU related code, like some kind of bootloader making bootloader from the scratch, you eventually you will you will learn about like register stuff. There's like general purpose of register and special purpose of register. And the general purpose of register is known as AX, BX, CX, DX. It's like accumulator register and base register and count register and data register and those kind of stuff. And this AX can split into AH and AL, BH and BL. You know, I know this is a really some kind of really nonsense concept that you cannot really understand. Me either. I was not able to understand some kind of this. But let's say like this. This H and this L stand for the high bits and low bits. So why is that? Let me try to uh, give you a drawing of it. You know AX, the size of the AX, BX, CX, or DX. These are general purpose of register, and the size is 16 bits. Let's say 16 bits. And in 16 bits, AH, AL. 8 bits and 8 bits. Yes, the reason of splitting into AH, high bits and low bits, is because it can split into 8 bits. Why? But why do we have to split it? Because when we're trying to store a little bit like small size of data, we can just use 8 bits rather than storing into 16 bits. So the reason why we divide into 8 bits and 8 bits is make it flexible to store something, right? And BX and DX and those kind of things. But I'm just gonna try to explain the core thing, what I learned, The fascinating thing was the CS code segment and instruction pointer. But why these are important? Why? Why I need to learn about code segment and instruction pointer? Why? Because this is kind of related to the memory address that we are trying to find. Uh, like if you're trying to like make some kind of application, you ask for the memory for an operating system, right? So operating system has to know about which memory should send it to it, and it has to track current reference or current pointer of their memory. And this code segment register and instruction pointer is the one who makes it like that. Let me try to elaborate more. What I believe about code segment is, you know, if you look at the memory, it doesn't look like this. Let's assume this is the memory. And these are the segments, right? And what does code segment do is, I think code segment is the one who store the starting point of the segment, and the size is 16-bit of it. So it stores some kind of the starting point of memory address. Example, we like 0x00, and of course it has to be lower than 16-bit, right? And it's stored in here, and of course this is going to be 64 gigabyte. It's stored in 16 bits, and after it's stored in here, we store the starting point of the memory, right? So code segment is the one who just storing this, and instruction pointer is the one who store the next instruction will be. Example, I'm just going to try to find the example of it. Here's an example. I think there's like assembly code of MOV, just move, and there's kind of specific memory address. Let's say like 0x00 and 0xf8000, and I think this is the next instruction, so it has to be stored in the instruction pointer. But why we have to store this kind of stuff is the CPU is gonna be make the physical address based on this kind of information. So code segment is the starting point of the memory, and instruction pointer is the one who will be executed in the next instruction. So the formula of getting physical address, fetching next instruction requires some kind of memory address, right? The physical memory address, and the formula of that is code segment is called CS, and this instruction pointer known as IP or program counter PC, and CS times 16 because we are 16 bits, right? In the real one we are using 16 bits, and plus IP. So that is the formula of trying to get the physical memory address. Physical memory address. And based on this kind of information, CPU is gonna fetch the next instruction based on that. That's pretty simple. So how do we make it like the front-end development? You know, I'm a front-end engineer, but we have to utilize it into our code, right? So this is what I'm trying to do. You know, you cannot make like a bootloader code or some kind of the logic that will activate the hardware, because JavaScript is runtime system, so it cannot be really interact with the hardware. So what I did was making a class of like instruction pointer, let's say IP, and put here, and let the private let's say buffer, because the size of the instruction pointer is 16 bits, right? It's gonna be let's store like new array buffer of two of it. New array buffer two. One, because one is 8 bits and 2 is 16 bits, right? And this is the buffer, this is the size of it. After that, we can just construct the we can just construct constructor. We can just get it and get offset, which is gonna be like we have to manipulate this kind of array buffer using data view of it. So we're just gonna make it new data views instance and put the buffer here. This the buffer, and sometimes we have to, and you just have to return it. But I forgot the how to write the code about the making starter point. Yeah, it is like data view and data view like get uint16 blah blah. So like, and starting from the 0 offset and make it true, and we have to just return it. So this is just how to get offset in the front-end development, because even the front-end development you can just declare the array buffer, because to store is a kind of 8 bits or 16 bits rather than some kind of new array. So this is what I'm trying to do right now, making instruction pointer in the application level of it rather than hardware, and utilize it with the new class using CPU of it. So CPU, we're gonna get this IP or code segment class, and we're just gonna utilize it into some kind of making this kind of logic, right? Because to make the logic, I just have to get the code segment base address and times 16 and instruction pointers, the offsets, right? And that's how CPU. So that should be inside of the CPU class, because this is the logic of the CPU, right? So this is how it's done. It was pretty kind of hard to understand first time, but it's kind of simple. But next time, what we are trying to do is we'll utilize this stack. I forgot the word of it. It was like stack segment, and we'll utilize it as P and SI, make it how CPU handle the stack memory. So this is it. Have a nice day. Bye bye.